Welcome to In 5 Minutes. The agenda of this clip is to identify the region of operation for my NMOS and PMOS transistor for the regions C, D and E. In the previous clip we have seen that for region A, my NMOS is in cutoff whereas my PMOS is operating in the linear region. For region B, when my input is equal to VIL, we have seen that my NMOS operates in saturation whereas my PMOS operates in linear region. At the same time, we have also seen the corresponding output. For region A, my output, because input is less than the threshold voltage of NMOS transistor, which meant that my NMOS transistor was off, and if NMOS was off, my PMOS was on, and my output was pulled to a logic high, which was nothing but output high. Again, in case B, when my input was low, my output was still considered as logic high. But remember, input low, but it was the maximum voltage considered to be a logic 0. So the output is still high, but it's not as high as VDD. It's approximately equal to output high. If you have not understood what I just said, just keep this in mind that my input is low, so my output is going to be high approximately. Now we go to the case 3 or switching threshold. Now switching threshold is nothing but, remember, it's different from the threshold voltage. If I have a CMOS inverter and if this is my voltage transfer characteristics Vout and Vin, my output is going to remain high for a certain period of time and after that it's going to go low. This is an ideal case. And in an ideal CMOS inverter, you want your output to transit or switch at a specific point. And this point is nothing but switching threshold. Switching threshold is a point where your input is equal to your output in an ideal case. Just remember this much. And if I have a range of supply from 0 to 1.8, technically switching threshold should be at the center, that is 0.9. So let's get started and identify the region of operation of my NMOS and PMOS transistor when the input is switching threshold. Let's first do it for NMOS, then we'll move it to PMOS. For an NMOS transistor, my VGS, which is nothing but equal to Vin, which is nothing but equal to switching threshold because my input is nothing but switching threshold, not the threshold voltage. This switching threshold is nothing but approximately equal to 0.9. It will be greater than the threshold voltage, which is 0.7, so my transistor is on because my VGS is greater than my threshold. Now what we need to identify is whether my transistor is operating in the linear region or in the saturation region. For that, let's write VDS dash VGS minus VT. VDS for NMOS is nothing but Vout, VGS is Vin minus VT. Now we have just seen that for switching threshold, my input is equal to my output. So input and output both are same. If this both are same, here there is additional term getting subtracted from this, so this is definitely going to be a greater than sign. So this shows that my NMOS transistor is operating in saturation region when my input voltage is nothing but switching threshold. Let's identify the region of operation of our PMOS transistor at the same time. VGS dash VT. Let's first see whether the PMOS transistor is on or off. VGS for PMOS is nothing but Vin minus VDD dash VT for a PMOS. Vin is nothing but switching threshold, which is equal to somewhere around 0.9 minus 1.8 dash VDP, which is nothing but minus 0.7. This is nothing but a less than sign. So my NMOS, my PMOS transistor is also on. What I need to identify is whether my PMOS transistor is in linear or in saturation region. For that, let's quickly write VDS dash VGS minus VTP. VDS is nothing but Vout minus VDD. VGS is nothing but Vin minus VDD minus VTP. VDD get cancelled. Vout and Vin both are same. But remember, VTP is a negative value, so this negative and this negative makes it plus. So this is nothing but plus VTP. So it's a clear case that this is just a value. This is this value plus some value, so it's going to be a less than sign, which very clearly from the table, we can say that my PMOS transistor is also operating in saturation region. So in region C, where my input voltage is switching threshold, my NMOS is in saturation, my PMOS is in saturation, and my output is also going to be equal to switching threshold because input is equal to output. Very straightforward.